Hi, I'm Miss Fu. Let's have a look at relating the gradient function to the original function. Here I have the original function. Here I'm going to sketch the gradient function. Before we start, let's see what it might look like. So I use the pen to estimate gradients. So here we have a very positive big gradient. Here we have still positive but less big, still positive, and it's getting smaller and smaller and smaller and smaller, zero gradient. And then here we have positive, positive, big, positive, huge gradient. Let's pick some x values. I've picked -2, -1.5, 1, etc. And I'm going to figure out the gradient for each of these points and then sketch it over there. My equation is a half x cubed for the original function. So -2, let me put the dot there, I'm going to draw a tangent. And we can see that the gradient of this tangent, rise of 6 over run 1, is 6. So on my gradient function, I'm going to plot a -2, the 6 over there. So I figured that out. So at -1.5, what's the gradient there? I'm going to draw a tangent again, and I can see that rise over run, it is 3.375. So I'm going to put a -1.5, a dot there. Then a -1, I'm going to draw a tangent again and figure out the gradient for that tangent is -1.5. Sorry, 1.5, it's positive, not negative. What was I thinking? So here I'm going to sketch a -1. I'm going to put a dot there. So these are the gradients of this graph. I'm going to do that 0. So I'm going to do a few. I'm going to do it 0 as well. At 0 it's easy because it's just 0. So at 0 I'm going to draw a 0. Now at let's do 0.5. Draw a tangent again. You can see that the gradient for that line is 0.375. So at that point I'm going to put the dot there. At 1 and see the gradient is 1.5. So at 1 I'm going to put a dot at 1.5. So remember, these spots here are the gradients of each of these spots here. So we can see that the gradient function, this is the gradient function, looks very much like a parabola. So when I join the dots, original function, gradient function. So see, and we got the gradient by looking at the gradient of each spot and then plotting the gradient as their y value. Let's do another one. Original function, let's do the gradient of this one. This one is a fifth x squared. Again, we're going to pick 5 spots and find the gradient of each 5 spots and then plotting the gradient over there. Pause the video and give it a go yourself, and I'll pause to see the answers. So step 1, find the gradient of each of these spots. So at -5, let's draw a tangent. Find out the gradient of tangent, which we calculated to be -2. So at -5, we're going to draw -2, dot there. -2.5, put a dot, draw a tangent, find the gradient of tangent. We can do it quite easily. You can see that it's 1, 2, 3, -4 across 2, so it's -1. Sorry, -2 and 2. Yeah, it's -1. So -1 over there. And then at 0, we can simply say that it's just 0. And then at 2.5, we draw a tangent, and we can see that this tangent has a gradient of 1. And then at 5, we draw a tangent, and we can see that the tangent has a gradient of 2. So we can see that the gradient graph is a straight line for this parabola. Example 2, where we have y equals 3x as our original function. Well, we know that the gradient is just 3. So our gradient function should be just 3. But let's test it out anyway. So here we have a few spots, x values, sorry, and we're going to figure out the gradient for each of them. We can see that it's always 3, but you can manually work it out too if you want. So at -3, we can see the gradient is 3. -1, we can see the gradient is still 3. At 0, the gradient is still 3, etc., etc. So it doesn't matter what points we pick. the gradient will always be 3. And we can see that the gradient function of the original function will be a straight line. Thank you for watching, and it can get a little bit confusing. Go back and look at all these examples of the original function and the gradient function and try them out slowly yourself, and email me for questions. Thank you for watching, and I'll see you next time. Bye!